Number 40. Find the missing term of the arithmetic sequence. I've got a first term. Well, that's nice. I've got a second term. Do I know a pattern? I wouldn't know a pattern if they didn't tell me this. It's an arithmetic sequence. So our difference, we're going up. It's 13 minus 3. We're going up by 10. And I've got a first term. Now, the author was kind to us, so we could probably just say, well, the third term is 23, up 10, then 33, etc. But what if this was the 98th term? That would be inconvenient. I'd probably like a formula. So my nth term is equal to my first term plus how many steps? N minus 1 steps to the nth term. What's my difference? 10. Positive 10. So in this case, my ninth term that I'm looking for is 3 plus 9 minus 1 times 10. And we can hire out a fifth grader to finish that one for us. 3, 8 times 10 plus 80, 83. If it was only all that easy. 53, we've got the series here. The sum of a sequence is a series, 2 plus 4 plus 6 plus 8. It doesn't take long to take a look at this and say, yes, that's arithmetic. Okay, we do have a formula for this. It'd be fun to kind of explore that formula a little bit at a later time, but our formula says that if we knew what the average term was, we could multiply that times the number of terms. But our average term is a breeze. If it's arithmetic, our average term is our first term plus our last term divided by 2 times our number of terms. Well, 2, 4, 6, 8, 10 terms here. It's our average term times our number of terms, or 22 on 2, 11, times 10, 110. Similarly, 58, find the sum of the first 100 positive odd integers. Let's take a look at what those are. 1 plus 3 plus 5 plus 7 plus ... plus, boy, I want to make sure to get that last one right. Is it 199? Is it 201? Somewhere around there, we better make sure we have it right. Well, what do I know? I know my first term, we start at 1. How many steps to our 100th term? 99 steps. 99 steps of what? 99 steps of positive 2. That is 1 plus 198, or 199 is our 100th term. Okay? So our formula, again, is our average term times our number of terms. Our average term is our first term, so our sum of the first 100 terms is our first term 1 plus our last term 199 divided by 2. That's the average term. How many terms are we dealing with? 100. Pretty convenient here. We've got 200 divided by 2, 100 times 100, or 10,000. If they were only all that easy. Number 63. Find the nth partial sum of an arithmetic sequence. The sequence is 0.5, 1.3. How much are we going up? 0.8. How much are we going up? 0.8. And that's going to stay consistent. How do we know? It's an arithmetic sequence. Again, the author could have made this tougher on us by saying n is 60. We may just want to go add 0.8, add 0.8, add 0.8 till we get our 10th term, but I'm going to do this. Our 10th term must be our starting term, 0.5, plus, here it is again, how many steps to our 10th term from our first term? 9 steps of 0.8. So this is 0.5 plus 9 times 0.8, 7.2. Our 10th term is 7.7. So what are the sum of our first 10 terms? The sum of our first 10 terms is equal to our first term, 0.5, plus our last term, 7.7, divided by 2, that's the average term, times the number of terms, 10. 8.2 divided by 2, 4.1 times 10. Our 10th term is, or our sum of our first 10 terms is 41. And one last problem from this set, number 70. Find this sum. I'm going to start listing out some terms. My first term is 7 times 51. That is 357 plus 7 times 52. That's going to be 364 plus, until I get to my last term, conveniently, 7 times 100, 700. So our sum of those terms is our average term. There it is. 357 plus 700 divided by 2 times our number of terms. Well, maybe we should think in terms of steps. How many steps from 51 to 100? 49 steps. How many terms then? 50. The number of terms is always one more than the number of steps. And we will pass that on to an 8th grader to finish that work up for us. And tomorrow we will continue into geometric sequences.